Hi guys, we're going to do check your understanding on page 569. Okay, it refers to the perfect potato example on page 565, and what that perfect potato example said was that the potato chip company, potato chip manufacturer receives batches of potatoes, and if they have more than 8% blemished, like bad potatoes, they send the batch back. Okay, so our null hypothesis is that the proportion of blemish should be equal to 0.08. So our alternative hypothesis is that proportion is greater than 0.08. So if the proportion is greater than 0.08, we will reject the hoe and conclude that we have a bad batch of potatoes and send them back. So we take a sample of 500 potatoes from the recent batch, and we find that 11% of those potatoes are bad. Okay, so is it that big of a difference to send the whole batch back? Okay, so that's the gist of the perfect potato example. So we're going to talk about our type 1 and type 2 errors and which one's more serious. Okay, so let's talk about a type 1 error. So remember, a type 1 error, let me move this up a little bit. A type 1 error means the hoe is true, but we reject it. Okay, so the hoe is true, so the batch only has 8% blemish, but we reject it and we think it has more than 8% blemished potatoes. So what do? We send back a batch of potatoes that we think is bad, but it's really okay. So we send back a good batch of potatoes. Okay, because we think they're bad. So what are some consequences here? Well, if we're at the potato chip manufacturing part, we've sent back our batch of potatoes, so we can't make potato chips for the day, so we got to wait for another batch. I don't know, wait another couple hours, wait a couple days, who knows? Okay, so we need to wait for another batch of potatoes so we can make our potato chips. Okay, so we're just standing around waiting, whatever. Okay, let's do type 2 consequence. Oh, type 2. A type 2 error is when the ha, or the alternative hypothesis, is true, but, so this is true, but we fail to reject the hoe. Okay. Okay, so in this case, our batch potatoes is pretty bad. It's got too many blemishes. We don't want it. Okay, but we don't think it is bad. We mistakenly say it's okay. Okay, so basically we keep a batch of potatoes that has too many blemishes. We keep a bad batch. Okay, so what are the consequences here? Sorry, hit my iPad. So what are the consequences here? I've got a bad batch of potatoes, which I think is okay, but it's really bad. So I go ahead and make my potato chips. But my potato chips now are going to be, I don't know, maybe not the best quality, okay? So I make chips that might not be the best quality. Won't be of the best quality. Okay? So the question says, which is more serious? Well, let's see. This is going to waste time for the production because I got nothing to do waiting for another batch of potatoes, okay? But this is going to cause my customers to complain about my product. So I would have to tend to think from my company standpoint, because maybe I can think of some other stuff for them to do in the factory while we're waiting for potatoes, like maybe clean or organize. But if I start selling bad potatoes, my customers are going to start complaining, and they're not going to buy my potatoes anymore. So I think type 2 is worse, okay? So you're just going to have to think through and justify your choice. So I think it's worse for me to sell bad potato chips and have my customers complain and not be happy than it is for me to wait a day for another batch of potatoes. Okay, so I think type 2 is worse in this situation. Okay, based on your answers, would you choose a significance level of 0.01, 0.05, or 0.10? Okay, well, let's see. if I wanted to be able to reject, if this was true and I wanted to be able to reject my hoe, I want my P to be low. Okay, so if I want my P to be low so I can reject the hoe and have proof that the batch is bad, I'm going to want a higher alpha value. Okay, because remember, we compare P to alpha. So if I have these three different alphas, okay, I want to ensure that my P is low. So this one will give me a better chance that my P is low so I can reject the hoe and send back a bad batch and not have to commit a type 2 error, okay? If I chose a alpha of 0.01, that probability had to be really, really small to be less than 0.01. But over here, my probability, I've got more opportunity for different probabilities that'll be less than 10%, okay? So that's the one I would want to choose to ensure that my P is low so I can reject the hoe and know that my batch is, and feel confident that my batch is bad, okay? So that consequence doesn't happen, or that type 2 error doesn't happen, okay? All right, the next question. Tell if each of the following would increase or decrease the power of the test and justify your answer, okay? I'm going to fold my paper, if you don't mind, and bring this up. Okay, so if we change the significance level to 0.01, that would increase the power of the test. Okay, so increasing your alpha increases the power of the test. Okay, again, just from my example, what I said before, if your alpha is larger, you'll have more opportunity to reject the hoe. And again, that's ultimately what you want to do, okay? You want to make sure you're getting those batches of potatoes that are bad, okay? You don't want to commit a type 2 error, okay? B says take a random sample of 250 potatoes as opposed to 500 potatoes. Okay, well, if we have a smaller sample, okay, we know that that's going to increase the standard deviation of the sampling distribution, okay, which will impact our p-value, which will actually decrease the power of the test, okay? Okay, so when we make our sample size smaller, it actually decreases the power of the test. So with most things in statistics, the larger sample size is better. Increasing your sample size increases the power of the test. Okay? C, insist on being able to detect that P is 0.1 instead of 0.11. Okay, well, let's see, P is 0.10 or P is 0.11. Okay, if we're going to compare these to our our null hypothesis, which is 0.08, which one's going to be, I don't know, a bigger difference? Okay, so if we compare to P 0.08, that's only a 0.02 difference, where this is a difference of 0.03. Okay, when you have smaller differences, it kind of decreases the power of the test. When you have a larger difference, there's a better chance. Oh, I'm sorry, you can't see that. When you have a smaller difference, it decreases the power of the test. So it decreases the power of the test. When you have a larger difference, that increases the power of the test. And if you think about it in terms of, let me go back to my null hypothesis. If this is a difference of 0.03, the bigger this difference is, the more chance I'm going to reject the hoe, okay, which is increasing the power of my test. But if the closer that my sample is to my null hypothesis value, it's going to be harder for me to reject the hoe, okay, because statistically they're going to say, there's really not much difference, okay. So the larger the difference, the increased power of the test you have, okay, and the smaller difference, you're decreasing the power of the test. So we always want to have the highest alpha we can have, the largest sample size we can have, And the biggest difference between the sample statistic and the population parameter we're checking against to give us the best possible scenario so that we will be able to reject the hoe, which again is our ultimate goal, because that's what's really going to cause, if I don't do that when I should, that's going to be the worst case scenario here for my type 2, my worst error in this case. Okay, so that's it, right, for that check your understanding. Alrighty, see y'all later.